Good afternoon.
Um, for those who don't know me or don't know my voice, I'm Rob Best. I'm the Director of Projects for ESW, and we've got Michael Potts with us from Sustainable Minds. I think many of you would have talked to Michael or have met him virtually through the webinar we had about a month ago now. Is that right, Michael?
It seems like only yesterday, but yeah, hopefully we've had some exchanges. Hi, everybody.
So thanks for joining us. This is one of two sessions we're doing to have the sort of final presentations discussion for the LCA+U projects. So I'll let everybody introduce themselves when they go ahead and talk, but we've got Eric Tank from RIT, Wesley Schoen from Georgia Tech, and Andrew Beck from Pitt with us. Just as a note to everybody, I'm recording this session, and I'll record the one this afternoon as well. So if you can't make the afternoon session but want to hear what other chapters are doing, you can feel free to watch that. It'll be on our website for members to view afterwards. So without further ado, I want to go ahead and get started. So Michael, did you want to say anything before we turn over to the teams here?
Only that we're excited that the teams have applied themselves to the projects, and for the ones that didn't notice, we did just upgrade the software, which will allow you to look at your models with a slightly different perspective. Like you, we're always trying to hit moving targets and timelines and never predicting in advance, but we're just open-minded, excited to hear what they've got to say, and looking forward to reading the reports as well as listening to the presentations.
Great. So Eric, I know you guys at RIT had to, you said you had to hop off in a little bit here, so I want to go ahead and start with you. I'm going to go ahead and unmute you here, and should I also make you a presenter?
Okay. Hello.
So I've made you the presenter, Eric. There you go. We can see your presentation. So perfect. Why don't you go ahead and take it away?
Cool. Sounds great. So good afternoon, everyone. My name is Eric Tank, and I've got a couple of other people in my team here. Good.
Okay. My name is Nihad.
Pedro. So, and a few others are trickling in. So we've been working on dining services, basically a takeout container, lifecycle analysis. Our campus has 18 different dining service locations. They all use different takeout containers, and there's no idea how the environmental impacts work. So we've got everything under the sun. And at least one of the guys have actually been, proactive in trying to be more environmentally friendly, but it's been more shot in the dark style. And they recently approached our campus sustainability advisor saying, hey, can you help us out? Which was conveniently right at the beginning of this proposal process to try to find something with the whole LCA+U challenge. So we took this up, and we worked with the dining manager who's been who has the most interest in this and has been very proactive, along with one of the facilities directors who's kind of responsible for logistics working with dining services, and then our campus recycling manager and sustainability advisor as well. Along with the support from both the ESW group and Sustainable, try to get all these. So our approach was to first explore just what materials can be used for takeout containers, because there's only a handful of common polymers and materials. And so we looked through all those, talked with one of our the local vendor for seeing why are some of these used or not used, and really narrowed it down. We worked to find samples of each of these types, including the ones that are most commonly seen on our campus, and then also looking at some of these new ideas that we came across. Thankfully, these are quite straightforward and simple. Most of these are only one material each. A couple of them have 2 or 3. So we weighed each of the takeout container options, both current and proposed. Doing our research on this, we found that virtually every single item out there right now is currently coming from China, so the modeling for the location was pretty straightforward. But then one of the ideas we came about, which will be on the next slide, was a washable option. And so for that, we worked with one of the campus kitchens to look at the current dishwasher we have, what sorts of energy inputs we'd need, and just how could we possibly model this to figure out a use phase. So going down to the actual alternatives now, we currently use a molded sugarcane bagasse clamshell. It's the bottom left of the screen, not that it's a great image there. But it's just like the sugar cane after they extract sugar from it. And they press that into a container. There's a version that's lined with PLA plastic so that it's more water resistant. That was a new idea. We also had one of our several facilities currently use paper plates and just cover them with aluminum foil. And they use little molded pulp trays for side dishes. Another one uses a formal polypropylene tray with lid. And then we also found oriented polystyrene, which is number 6 plastic. Same stuff as styrofoam, but it's just not poofed up. And so that is a recyclable plastic, but while we modeled it to see what our current impacts were, that one was not in our consideration for a future successful container because we're trying to phase out all forms of polystyrene on our campus for health concerns. We also looked at number 1 PET plastic, which is another clamshell just like the polystyrene. Then we also found this reusable clamshell, which is in the upper right-hand corner. It's a very heavy-duty polypropylene clamshell that could be washed for several hundred uses. So we used the basis of this reusable option to model the functional unit that we used, which was basically 360 containers, because one of those reusable options is theoretically going to last for at least 360 washes before it breaks. So we used basically each of those that's on the screen as the different alternatives that we then modeled. And then we worked mostly in the version 2 of Sustainable Mines, but we did remodel it in the version 3 today, and it turned out a lot cleaner. Though, so as you can see on there, most of it's in the manufacturing step, basically just the materials themselves. And so we found of the current uses, the sugarcane bagasse clamshell, which was a new addition to our campus less than a year ago, and that was the shot in the dark I referenced. Turns out to be a really good option of the single-use options. Transportation was also pretty significant. But the interesting thing is we weren't able to get all of the data that we truly need for this, in part because we don't, or I should say we didn't get enough time to find the exact types of vehicles used to transport these. We know they're all from China. We don't know exactly where. We're assuming they're all going on the same methods to get from there to here. So the transportation phase may be a little larger or a little smaller, particularly because there's also dimensional weight that we weren't able to account for. We just did this straight up, how heavy are they? Then for the manufacturing itself, relative to each other, they should be just perfect. But all of the data out there is mostly European in origin, and since this is China, we expect that their energy use is going to be a lot dirtier. So the manufacturing phase is probably going to be larger than what's actually modeled. But relative to each other, it should be exactly correct because they're all roughly the same location of the world. But the interesting piece is going off to the far right. What we think is our best conclusion was this reusable option that was brought up. It's the same option, 2 different columns. The left column is the absolute worst case scenario energy being used because there needs to be a take-back system for these, and we identified a kiosk that could do this. But we have no idea how much energy the kiosk actually uses. The manufacturer was not exactly forthcoming with that. So we modeled the absolute worst case scenario based on nameplate capacity, was the left column, and then more realistically, assuming there's some kind of power savings feature, things like that, is the right-hand column. And there is interest on our campus already to do this, and we had a sample out at our a big creativity festival we had last week, 2 weeks ago, on our campus, where a lot of people in the public came by and sold these, and they loved the look and feel of that container system. So going forward as kind of a conclusion, we think that this, as a single-use option, the sugarcane bagasse is easily the best one we've got. Overall, though, if we can manage to wiggle out a reusable system, that is clearly so much less on the impacts that we think this would be a fantastic system for the university. And while we don't have real financial data for it, just doing a basic preview on the internet on what we could buy each of these at, the reusable option would be about 1/10 of the cost of the single-use options. But again, we weren't able to get RIT-specific data for that. It should be noted, though, that for the reusable option, this was highly RIT-specific because of the way our dining system washing system works, so it may not work elsewhere. We basically had, this is a marginal impact for the reusable. So we think it's pretty good. But again, our dishwashing system basically has excess capacity that we're not using, and it uses the same amount of energy whether or not it's running with stuff in it or without. So we had the extra soap, the extra water, or whatnot, but the actual energy itself is not a part of the reusable modeling for that reason. So going forward, if we were to keep working on the LCA, we would ideally figure out exactly where are these actually manufactured so we can get the actual transportation information along with what actual vehicles are used, now that that was a fairly substantial chunk of the impacts, particularly as they're leaving campus as well. We know where the landfill is, we know where the recycling facilities are, but we don't, whether it's using a garbage truck or using a transfer station to move to something else makes a big difference on how big the impacts are of transportation there. But also, if there's some way to be able to model the Chinese energy sources as opposed to the European ones for the manufacturing, that probably have the largest impact of these. And as for implementation, our next steps are to try to figure out the university pricing, or at least work with the powers that be that have access to that, to see if the reusable option or the sugarcane bagasse truly would be viable moving forward. And if the reusable option is, in fact, as interesting as the dining managers think it is, to figure out where could we actually place these kiosks and logistically how would we empty them, how would we physically collect these back, and then formally write up a proposal with them for both of these options and present it to dining services next. And they have already asked for a copy of our report, so there's definitely interest in this. So that's kind of where we are. So, any questions if we're doing Q&A?
Well, before I get in with questions, can I compliment you and the team on just managing this and making it, you know, a very clean presentation. Well done.
Oh, thank you.
Yeah, I would echo that, Eric. You guys did a very good study here, and I found it very interesting because my old campus, Harvey Mudd, went to this system, the recycled polypropylene that you talked about 3 years ago, and I never saw an LCA that was actually done on it. So it's interesting to see the way that pans out. That it actually is better for all of the claims that are made. I did notice. First question I had is I noticed that on those you didn't have any sort of end of life or disposal scenario for the polypropylene. Did you consider that at all? Did you consider what the average lifetime of those might be? How readily they might break or have to be replaced?
For the reusable ones?
Yeah.
We figured, so the only way we can make that actually work is to have a fairly hefty deposit. I mean, like $3 or $4 deposit, whatever would cover the cost of a new one. And that's why we'd have the kiosk system. So we figure at their end of life, even if they shatter while a student has them, they're still going to return it to get their deposit back, which means that we have complete control over where they go. So we would assume 100% recycling rate for those. And the way the software models it, which we thought was really cool actually, it would add nothing to this particular graph because the cost of recycling would go into the recycled polypropylene material itself. Gotcha.
And anybody else out there, if you have a question for Eric or the team here at RIT, I know I've got you muted here, but if you send me a chat or raise your hand, I'll unmute you so you can or unmute yourself actually to ask a question. But Michael, do you have any questions?
I don't have any questions. One observation that's interesting is transportation is often studied and rarely becomes the issue. People study it to realize that it isn't the main issue and then get focused on something else, except when they're actually doing supply chain logistics. So I am surprised transport's come up as, you know, the 20-30% factor in this. It's just an observation that's rare from the ones I look at. Nothing more than that, and obviously the reusable, recyclable solution, you know, it would appear, and I love the way they bracketed it to manage what they don't know, certainly is worth exploring, and you know, even if it is 10 times more expensive, it's 50 or 300 times more less impact on the environment. So.
Yeah, we were surprised to see the transportation be such a large chunk, but when you really look at it, the end of life isn't much with the new modeling system and for a lot of these at least, and there is no use space for most of them. So I guess it makes more sense then, because it is going halfway around the world.
Yeah, definitely. Do we have any other questions here for Eric and the team at RIT?
Is there any North American source for the big ass one?
We're not sure.
Because that would be another thing to look at.
Yeah, it would be very interesting. So there are a few producers in our country, it seems, but they're hard to find. And to extend that, the other thing was PET and polypropylene both do have recycled versions, but we found one source of recycled PET clamshells and could not find any more information on them at all. So it'd be interesting to see if people are actually doing that. That would cut down a lot of manufacturing.
Absolutely.
We're just getting through the selection of 8 down to 2, and being able to now focus in on executing well appropriately those 2 is exactly what we're trying to provide with the model to help people focus in on which are the ones that are most likely to have the best outcomes. And this is where it's just a really nice example of helping you display that, and then it'll help other people make better decisions because of your work and analysis.
Indeed. It was great to actually see a conclusion that was so clear, too. I think this graph will be copied around campus quite a bit, I think.
But it won't be just your campus, I should think. But anyway, no further questions.
Cool. Thank you.
Great. Well, thank you very much, Eric. That was a fantastic presentation, a great project, and we're excited to see where you guys go with it at RIT if you actually do implement changes here to the way that takeout food is distributed as a result of this. But let's move on here to Wesley. Are you there?
Yeah, I'm here.
Great. Do you have a PowerPoint or anything that you want to show, or are you just gonna?
No, I just have some data here.
Okay.
To talk about. So this will be more of an internal update. Unfortunately, most of my group seems to have left me. So I'm pretty much the whole Georgia Tech team. But so we have some data that we got from this year. Oh well, first our project is to look at the cleaning wipes used at the CRC, which is our biggest workout facility on campus, and to find a way that we could perhaps use a different material or something to reduce the amount of waste that's created by those wipes. So first we went to the people of the CRC, and from them we got some head counts and other data. So for example, like for the month of February, they had 34,705 visitors. So this is just like to help us know if we were to implement some a different method of cleaning, then how many people would affect. So we also gave us the data they had on the gym wipes, and we found that it was 79% water, 20% absorbent material, and about 1% cleanser. The containers are recyclable, made of high-density polyethylene, and they used approximately 144,000 wipes per year. And then they also have other cleaning solutions which we weren't focusing on because we didn't know about, but they have like other deep cleaning solutions which are used during like off hours, so that to clean the machines further, because they have to prevent things like MRSA and staph from contaminating the people using them. And so we disregarded the logs because those weren't really relevant to our study. And we also contacted the company trying to get more information on the materials they used for these wipes, and they told us that the wipes were biodegradable and that the chemicals were also non-toxic and water-soluble. But they didn't go very in-depth on how, like, which materials these actually were, and we asked them where they were distributing these wipes from, but we weren't able to get that data. So yeah, hopefully during the next fall, like I've done some of the LCA work given the data that I have, but next fall I'm hoping to get a new group from the incoming freshmen when they hopefully join at orientation. So hopefully I'll be able to get people who are willing to work with me for the next phase of the project.
Oh, we hope so too.
Yeah.
So I wanted to just follow up a little bit on, in trying to figure out exactly what was in those wipes initially, it sounds like you just met with resistance within the company to actually disclosing the products. Is that right? Or
Yeah, we did.
okay.
They make it sound like they're pretty, both the people at the CRC and at the company sounded like it was important to them to have a product that was environmentally friendly, but they weren't very specific with us about the materials that they were actually using.
Now, what was the what's the actual disposal method of these wipes currently in the campus recreation center?
I believe they go into the trash cans and just thrown away.
Okay.
144,000 of them.
Yeah.
Yeah, because it sounds like even in the even if you're unable to get that data from the manufacturer, just the amount of waste that's generated by, as Michael said, 144,000 of these wipes annually, that's huge. And just even if it's an environmentally friendly product, generating 144,000 wipes worth of waste is not environmentally friendly, especially assuming landfill disposal. Do you have a sense, Michael, how much that end of life typically might make up for a product like this?
I'm not going to hazard a guess. The interesting thing is just I was going to throw out, we have put in a baby wipe model as an example that anybody can download in the new version of the tool, and it's just a reference, but it hasn't got the end of life plugged in, but it's, you know, it'll sort of stir the debate a little bit about what goes into which wipe. But to me, not being able to get the information is what should be the issue. This is a lot of material. If people aren't prepared to say what that material is, my warning signs go up usually. So.
Right. Okay.
Yeah. Is there?
We also looked into. Oh, sorry.
No, go ahead. Go ahead, Wesley.
Well, we had been looking into using like a cloth and then some sort of environmentally friendly spray to just like to have the cloth cleaned then after and reused. But the main problem that we had with that was that these actually they need to be there are certain standards that we need to hold to, which is the main ones being combating the MRSA and staph infection. So unless we can find like because all of the alternatives we had before were not officially cleared to meet these ends, so they could not have been implemented by the CRC. Even if we had thought that, even though there is data showing that some of them would work for this, it's not official accepted data, so it wouldn't be able to be used. So we started looking into more materials that we could just replace, but it would still, of course, be the same amount of waste that was used, that was produced.
Yeah, I mean, one thing I would be interested in is, could you produce a wipe that was 10% smaller?
Okay.
You would have 100% efficacy. People would just be more careful how they held it. Because if I use a wipe, you know what, I pick it up, I roll down the bar, I actually use the wipe contact to the bar, probably 40–50% of the cloth, and the other bit was just touching my fingers or waving around.
Okay.
You know,
Yeah.
50% reduction could be out there just by cutting them in half.
Right. Yeah.
Which would, not change any of the other requirements, but would be, I think you've got to look at different ways of addressing the problem. They've got a solution that works. It might be quite a green solution, but if you weigh up the output, you can certainly come up with questions, how do we still make it greener?
Okay.
So how can I reduce the total amount of going to disuse but still maintain the amount of usage? It's not always just replacing it that's the solution. There are other things out there.
Okay.
Great. Well, we'll be hoping, Wessa, that you can get some students to help you out either this summer or going into next year. And if there's anything that I can do to support you on that, please let me know, or perhaps you and I can follow up a little bit after this, and we'll just talk through kind of the next steps.
Okay.
And I would write up something with, some reality on what didn't work, and also, what you're going to do differently, or what you're going to do more of.
Yeah. Yeah, I mean, it's a great learning experience no matter what. So.
Okay.
Well, fantastic.
Great.
Thank you. All right, so that leaves now Andrew. Andrew, are you with us?
Yeah, I'm here.
Fantastic. Do you have a presentation that you'd like to show?
I do not, but I also have some data and results.
Awesome. Then the floor is yours.
Fix this volume real quick. Are you guys getting a weird echo from my mic or anything? Because this room is a bit odd.
You sound special, but we can live with it.
Okay. All right. So, yeah, I'm just going to do this in talk format. The problem we addressed, or after meeting with our stakeholders, we decided to address was the heating and lighting systems within the largest and most frequented on-campus library. This has a very large visibility, which is part of the reason we picked it. The building was actually constructed in 1968 and hasn't really undergone any renovation since then, so it was in need of some analysis. And it will also be actually undergoing renovation in the next 2 to 3 years, which is why we specifically selected it, since there's the opportunity for funding of some of the ideas we might have. And what we chose within the building, the heating and lighting systems, were just that because of their large energy expenditures due to the age of those systems currently. And also they operate both of these systems 24 hours a day, 7 days a week, because of some initial silly design that made the switches in the building very inaccessible to employees. So this is like a very large chunk of energy that our campus is consuming. Okay. As for meeting with the stakeholders are actually facilities management on our campus. They oversee all of the on-campus buildings and grounds operations. Our initial meeting with them, we tossed around a lot of ideas. Green roofs were mentioned, but ruled out because of the issue of gray water plumbing and having to go into walls and separate plumbing for that, and eventually that just fell apart. And we decided on this older building and the energy systems therein. Specifically, we came to the conclusion that the most impactful technologies within these systems would be both for the HVAC, the insulation, the wall insulation and ceiling insulation, and for the lighting system, the lamps and fixtures. Corresponding, or trying to have correspondence with facilities management was very challenging. Sometimes we would just want them to respond to our emails, and that would take 2 weeks. Sometimes they would respond with a meeting request rather than just answering a question. It was sort of all over the place, but eventually we did get some data out of them, and I will go into that in just a bit. The alternatives we assessed, initially we created a rather large laundry list that was a bit unrealistic and was narrowed down later, but in the end the lighting system, can you guys hear me? I'm getting like background.
I can still hear you clearly, Andrew.
Yeah, we can hear you.
Okay, good. Eventually, for the lighting system, we concluded that just an analysis of more efficient bulbs, the T8 fluorescent bulbs, as they're known, would suffice. And for the HVAC, obviously, different types of insulation. For the types of insulation, we researched a variety of alternatives. The most commercially applicable and probably the best suited to this application would have been closed-cell spray polyurethane foam. And I'll go into why the HVAC analysis kind of fell apart a bit. But that's a good insulation because it automatically acts as a draft sealant. And that is like a huge chunk of your insulation effectiveness. We also looked at cellulose, which is easy to install and has a high recycled material content, and a couple other newer fringe insulations. Our analysis, when it came time to do, we looked at some energy modeling software, specifically eQuest from, I believe it's either the Energy Information IEA or the EPA, I forget which, but it's basically just a building energy modeling software. And we were planning to use this for both the lighting and the HVAC. After some more thought, we realized that we could do the lighting just with the data we had, which was basically just an Excel spreadsheet with different lamps throughout the building, different fixtures, and their power draw. And in our model, the lighting system is operated 24/7 for every day in the year except roughly 5 days due to downtime from holidays and the gap in between the spring and summer semesters. A lot of energy, but that's how they operate. And whenever we did our phone conference with Michael and you, Rob, we were advised that the manufacturing and transport and end-of-use phases were negligible relative to the energy savings from switching to an alternative and the impacts of those energy savings. So our analysis consisted basically of different energy consumptions and a certain energy profile based on our region. So using the power data, we multiplied that by our time frame. The functional unit of our assessment is 1 year of service, just to keep it simple. And we divvied up the energy based on the energy profile of our region, which is roughly 48% coal, 34 nuclear, 14 natural gas, 1% hydro, and 3% other, which was mostly wind. And we also went out on a bit of a limb and tried to make a reasonable prediction of a future energy scenario for our region, which is basically just a 12% decrease in coal, a 4% relative decrease in nuclear based on an increase in energy consumption, and a 16% increase in natural gas. And these are all for electricity production because it's the lighting system. The HVAC analysis did not come through or has not yet because of limitations in the data we were provided with. We did get steam data for an entire year, but we've had trouble contacting facilities for the past few weeks now, and the only data we would need to complete that analysis would be just building parameters, wall space, information, in order to calculate total R values based on the insulation in the walls currently. Because the energy savings from a more effective insulation or a higher total R value are not linear. Energy saving is not linear to total R value. So we couldn't just do it on a basis of R value per inch of the different insulations, the current and the alternatives. So we're basically just waiting on them to finish that up. But yeah, we went forward with the lighting, and after doing calculations in Excel, getting kilowatt-hour numbers and divvying them up between sources, we and then looking at the difference in efficiency of the current technology, the T12 lamps, and the more efficient ones, the T8 lamps, we saw a 35% impact reduction from the current energy profile. And this was interesting because it actually correlates to, which we found in some literature on the internet, a reported 35% energy savings from a T8 to T12. This may have just been coincidental, or it might have some strange correlation. And then with the future energy scenario that we laid out, there was actually a 39% impact reduction. Recommendations for the future of this project and trying to sort of wrap it up, or for people who would do it, this sort of project in the future would just to be sort of to really keep the stakeholders active and communicating with them as much as possible, even if they're non-responsive. Our main constraint in doing all of this was just responsiveness of facilities management. So, yeah. Also, a clear timeline would help a lot. We had almost like every other meeting would just be me and another person, so attendance was an issue, but with a clear timeline, it might have been more manageable, and those might not have caused as much of a loss in the productivity of this whole project. Also, there's the possibility, both of the functional units for the analyses we were planning, or the one completed and the one incomplete, are 1 year of service. And we kind of tossed around the possibility of using different functional units, such as lumens for the lighting, which I suppose would give a more instantaneous view of the impact rather than over that certain time span of 1 year. And for insulation, possibly performing an analysis with energy reduction, because R value obviously doesn't linearly correlate to that. So I guess on a basis of like energy saving, that could be an interesting analysis. And moving on from there, some next steps would possibly be to include the manufacturing, the transportation, and the end of life for our products, or our alternatives and baseline. We actually put in all of our energy values on a 20-year time scale based on how long we thought they would be used before they'd be replaced by more efficient technology. I know the lamps currently in there have been, that model has been used for 20 years, and we just kind of made the assumption that these new T8 bulbs would also have that usage. So, yeah, because they only have roughly like a 3 to 5 year lifespan, I think that including manufacturing, transportation, and end of life could be an interesting addition to the analysis, just based on how many bulbs would be used. And yeah, once we have the wall space data from facilities, we could obviously flesh out our energy modeling with eQuest and finish that up. Also, would be interesting to include with that would be the large single pane glass windows on the bottom floor, seeing how newer, more paned, I don't know how to say that, newer windows with more panes would impact energy savings. And then we also initially wanted to perform a life cycle analysis of different occupancy sensors, but we kind of didn't know where to go with a functional unit, and thought it would be kind of relatively small relative to the energy savings of the lamps. And last but not least, and most importantly for facilities, would be the economic analysis and payoff times of switching to the alternatives we analyzed. Yeah, and that's where we've come in these few weeks or months. However long it's been.
Sounds like you've come a long way. Well done, Andrew, and your team.
Yeah, that's a lot of work you guys highlighted.
Yeah. It may have been an unrealistically large scope to begin with, but we were just really enthusiastic because of the potential for funding and responsiveness from our stakeholders. So,
well, 30–40% of probably a $100,000 bill is quite significant, you know.
Yeah, and that's just from the lighting, which is, I would actually venture to say, quite a bit smaller than the savings that would be gotten from HVAC, especially air conditioning.
I agree, and you could actually switch the lights off half the time if you put the switch in the right place.
Exactly. Yeah, it's a weird, I can't even, they explained it to me that it had to do with going into inaccessible breaker boxes or something, and that employees just wouldn't do it. And long, convoluted excuses for something that should be simple, but isn't.
Well, but the nice thing is there are automated, remote solutions at low cost that, you know, the lights for 30% is low-hanging fruit.
Yeah.
You know, a $20,000 solution that turns the lights off half the time has a 1-year payback.
Yeah.
We'll get someone's attention at the right time down the road.
Yeah, I'm sure of that.
No, I think you're right. You know, pick some big items, show them it's worth looking at them, so they make a good decision early on, and you know, the heating and lighting are two good things to go after for sure. I'm not really an expert in this space, Rob. What you can contribute?
Yeah, I mean, it seems like the conclusions that you guys have come to, Andrew, are in line with a lot of sort of predictions or practices for building models. It's definitely a very large challenge to take on, and we kind of talked about that at the beginning, just because there's so many materials you can tackle, so many systems, and getting a thorough analysis can be tough. But the one that you highlighted for insulation, I think, is a very interesting one. That there's a nonlinear relationship between the thickness of the insulation and the benefit that it provides for the building, because too often that's just prescribed as a means for improving efficiency, but that marginal returns means that you may start to get, I don't know if you've mapped this at all, you may start to see, for the same dollar amount, better savings from them looking at lighting like you did, where we're replacing the T8s with T5s or other new bulbs, or looking at your heating and cooling systems. So I know it's listening to is very interesting. Now, as far as what the university is going to do with this, what do you think their priority is, or what do you think that they're actually going to try and advance?
So from what I've gained from them and actually like talking to their head engineer, they're very efficiency minded, and I have like no doubt in my mind that they were gonna do this on their own at some point anyways. I was just kind of here to provide the impacts.
Yeah.
And as far as the insulation goes, the only reason they haven't replaced it as of yet is because all of it is asbestos, and it's going to be expensive for them to fix. They're working on a pretty limited budget, so...
Yeah. No, asbestos is a really tough material to have to deal with in the removal.
And that's also why they haven't changed out the lighting, because as soon as you go through that shell to start to fix the wiring or change fixtures and things, you immediately run into asbestos.
Right. And building code dictates something that you've got to change. Yeah, fun stuff.
All right. Well, yeah. As soon as I get that data from them, I'm going to try and do some a little more rough modeling with eQuest, and then do a bit of an informal presentation for them and just lay out what sort of improvements they can make.
Very cool. Well, I know I would be personally interested in hearing an update just kind of on how they respond to that. Either shoot me a quick email or give me a quick call or something. Yeah. And just really curious to see how the universities respond. So.
Mm-hmm. And it was interesting. I know they're going to be 100% responsive because the idea of implementing a green roof was actually theirs. They've had very positive results on 2 of our buildings with green roofs, but the issue of gray water plumbing just kept coming back.
Yeah,
it wouldn't really be an opportune time to implement that without that additional system to put in.
Yeah, yeah.
So.
No, that does make it harder. Retrofitting gray water plumbing, whether for a green roof or actual dual flush or just having that separate system, really is often not cost effective and not environmentally effective just because of the amount of destructive renovation you have to do to the building. So, yeah, that's going to be a tough call for them to make. But if they're ripping out all the asbestos in the walls anyway, it may start to make more sense. I don't know. I don't know how the trade-offs look there personally, but very cool. And good luck with the university on that one.
Yeah, thank you very much.
Michael, do you have any other questions for anybody or final comments or anything?
Not really. I'm just excited that people are using data to drive better decisions. You know, whatever they model, that's really what we're trying to inspire. And I think all these teams have got those kind of conversations started, which is great.
Yeah, us too. I mean, this is really, really exciting to see the universities actually taking some of these studies and turning them into actionable items. So I want to congratulate all the teams on what they've done there. And this is only the first half too. So this afternoon, for anybody who can make it, in about an hour and 15 minutes, we'll have hopefully the 3 of the other teams presenting as well on their LCA projects. If you can't make that, I'm going to record that session as well, and all of these will go on our website. I'll send the link out to everybody if you wanted to listen in or listen to yourself present at a later time. I'll send everybody the link so you can do that. Otherwise, if you have any follow-up questions for Michael or me, you have both of our email addresses. Feel free to send us an email, give me a call anytime. Otherwise, thanks for being here. Thanks for sharing. Michael, I guess I'll talk to you in about an hour then.
Yeah, perfect. And I think, I do encourage them to write it up in a sort of way that's full of what to do next rather than what we did, because it's about moving forward. That's really the whole part of this initiative too.
Absolutely, absolutely. It's really about the next steps. This is a good first pass, but now it's taking the understanding you've got and turning it into something actionable. So, well, great. Well, thanks again, everybody, and I will talk to you all soon.